rate graph. What the heck? Okay, this is a rate graph problem. It says the function f is defined on the closed interval from -2 to 8. There you see -2. There you see 8. It's satisfied. Look, it gives us a point. F has a point, 2, 1. Okay, that's a point for f. Not this graph. This graph is the derivative of f. The graph of f prime, the derivative of f, I just said that, consists of 2 line segments and a semicircle. This is important to know. If they tell you stuff like that, you're probably going to be using geometry to solve for the integral. Okay? Letter A, it says, does f have a relative minimum, a relative maximum, or neither at x equals 6? Give reason for your answer. So they are telling us right here, which we know is f prime. So this critical value at 6, that's where f prime equals 0. So you know that's a critical value. Now, you should be able to look at it right now and say whether or not it's a relative minimum, relative maximum, or neither. What say you, Stews?
Relative minimum, yeah.
Let's see. At 6, this is a plus minus graph for f prime. What's the sign of f prime before 6? It is positive. What's the sign of f prime after 6? Plus, oh snap. So that means f is increasing, then increasing. So do we have a max or a minimum there? No. So it's neither. Whoa, that's an N. Okay, neither, because f is increasing, then increasing at x equals 6. Done. Oh, wow. I'm not going to have enough space to write here. Okay. B. On what open intervals, if any, is the graph... What's this line right here? Okay. Is the graph of f concave down? Now, remember, my stews, we're looking at an f prime graph. Okay. And f prime does tell us about concavity. Right? Right? Here, let's write a few things. Well, I guess this is not a very, well, anyways. We have f, the derivative of that is f prime, and the derivative of that is f prime prime. F prime prime is what tells you about concavity. Sorry, guys, I'm writing with my finger, not a pen. And f prime tells us about increasing or decreasing, because it tells us the slope. Well, what tells us the slope about f prime? F prime prime. So this one is also increasing, decreasing. It's giving us information about it, okay? Which also works the other way. If f prime is greater than 0, I'm sorry, no. If f prime is increasing, go ahead and answer that, is increasing, then that's you, Angela. Oh, dang it. If f is increasing, that means the slope of f prime is positive. And what is f prime? I'm sorry. And what is the slope of f prime? F prime prime, right? So f prime prime is positive if f is increasing, and vice versa. And what are we trying to find? Intervals of concaving down. Okay, so I don't care about where f prime is increasing. Where f prime is decreasing, the f prime prime is less than 0, therefore concave down. All right, you guys with me still? Okay, so where is f prime decreasing? -2 to 0, right? So I'm going to say -2 to 0, and I'm going to say x right there. Wow, everything's tripping out up there, huh? And I'm going to write it like this because you guys keep using brackets when you describe intervals of increasing, decreasing. Do not do that. You have to use parentheses, or you write in inequality notation like I'm doing right here. We're also decreasing from 4 to 6. So I'm going to say 4 to 6. And that's B. Concaving down. So that's my answer. Okay. Letter C. It says find the value of the limit as x approaches 2 of this crazy, ugly looking thing, or show that it does not exist, justify your answer. Now, how would you prove or find a limit? Okay, we're not allowed to use L'Hopital's until what? Yeah, if we get 0 over 0, then we're allowed to use L'Hopital's rule. For now, yeah, we have to find our right hand and left hand limits. So we're going to find the limit as we approach 2 from the left, and we're going to find the limit as we approach 2 from the right. Okay, actually, you know what? For the most part, because it's not a piecewise function, I think we could just do direct substitution. So let's do that. So what would this simplify to? We would have 6 f of 2 minus 3 times 2 over 2 squared minus 5 times 2 plus 6.
I think the bottom comes 0. That's why.
Oh, the bottom 0? Let's see. It's 4. This is 10. Then we're adding 6. Yeah, so this becomes 0. But what do we get up top? Just curious. Because if the top is not 0, I can't L'Hopital this fool. Okay? Yeah, so what is f of 2?
1.
Oh, it's 1. Oh, so we get 6 minus 6. So we get 0 over 0. Therefore, he's sick. Let's take him to the hospital. All right, so I guess I don't need the one-side limits right now. Okay, so let's take him to the hospital. We're going to go and derive the numerator and derive the denominator. So for the numerator, I get 6 f prime of x minus 3. On the bottom, I get 2x minus 5. So let's find the limit as x approaches 2 for this guy. So we have 6 f prime of 2 minus 3, 2 times 2 minus 5. Okay, the bottom is the easy one. That's going to be a negative 1. Negative. Oh, no. All right, now what is f prime of 2?
0.
Oh, shoot, it is. It's 0. So we get negative 3. So our answer? Dunzo. Okay, last one. Find the absolute minimum value of f on the closed interval from negative 2 to 8 to justify your answer. Negative 2 to 8 is the whole graph right there. All right. So we have 2 ways to approach this. We can use FTC, or I can kind of think of it like differential equations. You know how when you guys take the antiderivative of something, you get a plus c? And we can find the c that way. So there's 2 ways to do this. I'm going to do both because I want you guys to know both. Sometimes one situation like FTC is easier to use, and other times it's easier just to find the c. So let's do the antiderivative. Oh, wait, I don't know if that would work. I think we need FTC. Because do we have a defined f prime? We don't have a defined f prime. Right? Okay, so, all right, guys. So FTC this foo. All right, so we're going to go the integral from a to b. Actually, yeah, let's just do from a to b of f prime. Because we can find the area underneath f prime, right? This equals regular f of b minus regular f of a. Now, what's the point we do know of f? Okay, I want that because I want to go like this. I want to take this out and put 2. Wait, does it equal 2? No, it equals 1. And I want to take this out and I want to put 2 right there. All right, right? If we know that the x is 2, we know the y value is 1. Everybody cool? Okay, so now I can write this. I can say f of x equals 1 plus integral 2 to x. And then I'm going to use t instead of x now because I'm using x to define this function. I have this. Does everybody see how I got that? I took the b's out and I made these into x's. So there's your x's. And then I moved this 1, this minus 1, over to the other side. Yeah. Oh, and this is supposed to be prime. Good. Okay, does everybody see that?
Yeah.
So now it says find the absolute minimum value of f on the closed interval. now what I can do is I can test my endpoints and I can test my critical values. Now with the critical values, we can be selective on which critical values we try. So let's go see. F prime of x equals 0 at x equals what? -1, 2, and 6. -1, 2, and 6. Why do I write all of them? I want my grader to know, I want my grader to see that I'm looking for my critical values. Now I can rule out one of these right away because I already did rule it out. Which one did I rule out? No, it was 6 from A. Yeah, and how come -1 gets ruled out?
Because it's positive and a negative.
Oh, it's the slope is positive, then the slope is negative, which means this is a relative maximum, right? What's that? Yes, we'll test the endpoints also. And we want to make sure we do that because that's how we justify what we're doing. Okay, so we know -1 doesn't work, but 2 is a possibility. So we have to find f of 2. We have to find f of, what's the lowest x? -2?
-2, yes.
And our highest f is
8.
or x, I should say, our endpoint. Okay, so I got to test all those. Oh, man. Okay. I have, like, no space. Okay, I'm going to have to erase this. Always starting to top left when you guys are working. All right, so let's see. Let's do the 2 first. So we have 1 plus the area from 2 to 2. Hey, I like that. Don't you guys like that? What's that? What's the area from 2 to 2? 0. So this equals 1. So that's 1. All right, the next one. We have 1 plus the area from 2 to -2 of f prime of t dt. Okay, so we're going from 2 to -2. Let's look at that. We're going from here to here. Oops. Okay, so that means we have to find the area of each of those triangles. Now, because we're going backwards, we're starting at 2 and we're going to -2. That means we have to reverse the signs. And so when I find the area of this triangle right here, he's positive. When I find the area of that triangle, he is negative. Okay, so it's 1/2 base times height. So if I'm looking at this triangle, I'm going to show what I'm thinking so you guys can see it. Okay, it's positive 1/2, and I think the base is 3 and the height is 2, right? We're good? Are you guys cool with that?
Yeah.
Base and height. Okay, and then for my other one, it's going to be negative, so I'm going to say minus. It's 1/2, and what's my base on that one? 1, and then my height is 2. So this cancels out with that. I get a 3. This cancels out with that. I get a 1. I get 2. All right. So far, 2. This guy is winning. I have to check my 8. Now, really quickly, can you guys tell me, do you think 8 is going to be smaller? Yeah. You guys see that? If I go from 2 to 8, look at all the areas I'm going to be adding. Am I going to be adding any negative areas? No. I'm going to be adding only positive areas to the 1 that we have. And so you can rule it out with words. You can say what I just said, or you can just do the numbers, which actually I would prefer. So I'm going to go 1 plus from 2 to, what's that number? 8? Okay, of f. Actually, you know, words aren't looking that bad right now because now I have to find the area. Oh, you know, I can't find the area under. Oh, this is a circle, huh? I mean, I could. Okay, I'm going to use words now because I don't want to find. Because I could do this triangle, no problem, but I don't want to find the area of that. It's possible. We can do it. I'm pretty good at geometry. What's that? Yeah, you would find this whole area, this square, and then subtract. Yeah, like I don't want to do that. Yeah. Who wants to do that? You're crazy. Okay, I'm just gonna say this. You know, to show my grader that I know what the heck I'm doing. Okay, watch this. Watch this. I'm gonna say this is greater than 1 because the area, okay, I'm just going to say from 0 to 2, or 2 to 8 of f of t is positive. All right, so this is our minimum. Our minimum value is 1.